Okay, in this session, let us continue with two more problems on ZBus. So for this network, we'll have to build ZBus. We have bus 1, bus 2, bus 3, and we have a reference bus. In between bus 1 and 2, we have J.25 impedance. Between bus 2 and bus 3, J.05. And between bus 1 and reference, we have J1. Between bus 2 and reference, we have J1.25. Now, as usual, we should begin with type 1 modification, where we add impedance of the line connecting reference and new bus. So I'm going to start in this direction. I'm going to add the line having J1 impedance between reference and bus 1. That is this part of the network I'm going to start and complete the entire part. So J1 is the impedance that is being added. So new bus is 1. Reference bus has not been designated by any number, so we'll just call it as R reference bus. So R is reference bus, K is 1, ZK is equal to ZB will be applicable. So here we have Z11 is equal to ZB, that is branch impedance J1. So our Z bus will contain J1. Next we'll go to step 2, where I'll introduce bus number 2. So bus 2 will be new, bus 1 will be old. So K will be 2, J will be 1, type 2 will be carried out here. So corresponding ZB will be J.25. K is 2, J is 1. So formula is Zk is equal to Zji. I can take the values 1 to n. In this problem, we have 3 buses totally. So I should take the values 1, 2 and 3. It cannot take the value of k. K here is 2. So it should take only 1 and 3 when you substitute for I in the first formula. So Z21 is equal to Z11, which is equal to J1, and Z23 will be equal to Z13. And then coming to the second formula, Zkk is equal to Zjj plus Zb. We have Z22 is equal to Z11 that we have got earlier, which is J1 plus J.25, that is Zb. We get 1.25 J. So our updated matrix will be ZBus 2 cross 2 matrix. Z11 J1 and Z21 and Z12 are equal to Z11, so they are also J1. Z22 will be 1.25 J. So please observe here that Z23 is equal to Z13. This will not be applicable because in this step we have not introduced bus 3 yet. So only the first one, that is I is equal to 1, will be applicable. Now coming to next step, now we'll be introducing bus number 3, and line connecting 2 and 3 will be having impedance J.05. Bus 3 is new, bus 2 is old. So old because it is already existing in our previous step, it is old. 3 is been introduced, so it's new. So K is 3, J is equal to 2. So again Zk is equal to Zji, Zkk is equal to Zjj plus Zb. I can take the values 1, 2 and 3. Possible values are 1, 2 and 3, but it should not take K, so it cannot take 3. It can take only 1 and 2. So it can take 1 and 2 during the substitution. So Z31 is equal to Z21, Z32 is equal to Z22. So our Z31 will be equal to Z21. Where will we pick the Z21? From the previous updated ZBus, that is J1. Z31 will be same as Z13. Z32 will be equal to Z22. Where is Z22? From the updated previous matrix. Z32 will be same as Z23. Then second formula, Zkk is equal to Zjj plus Zb, and Z33 will be equal to Z22 plus J.05. So we have Z33 is 1.3 J. So then we get the updated ZBus matrix. Then we have one more step to be carried out, that is we are adding line between bus 2 and reference. Its impedance is given as J1.25. So J, see, it is being added between old and reference. So J will be equal to 2, R will be reference, type 3 will be carried out. Formula is ZBus new is equal to ZBus old minus 1 over Zjj plus Zb, Z1j up to Znj. Here reference is not there at all. So Z1j, Z2j, Z3j will exist because it should vary from 1 to n. Zj1, Zj2, Zj3. So that is Zj1, Zj2, Zj3 here will be applicable. So Z1, if we substitute for J, we have Z12, Z22, Z32, and here Z21, Z22, Z23. Pick all these elements from the updated previous matrix. So Z21 is J1, like that. Pick all the elements, and ZB is 1.25 because it is the impedance that is being added here. That will be taken. After simplification, we get this as our matrix, and then subtracting this second term from our z bus old will fetch us the final z bus matrix. Of course, z bus old is our previous updated matrix. When second term is subtracted from z bus old, we finally get this new z bus, and since we have completed the entire network, this is our final solution. Let us take up last sample problem, because most of the problems are just exactly the same as this, and the network will differ, the bus numbers will differ, procedure is exactly the same. So coming to the last problem, it's an examination problem, most frequently asked. Form Z bus for power system shown by adding elements in the given sequence between 4 1 1 2 3 1 4 3 by selecting node 4 as reference. See, in this particular problem, we cannot select the path. He himself has given the path. We have to just choose that path. Accordingly, we have to build the Z bus. So bus 4 is given as reference. So first he has asked us to add between 4 and 1. So 4 and 1. So since we have the since it's been detailedly explained in all the three previous problems as to how to approach, I will cover it up quickly. So R is equal to 4, K is equal to 1, between old and new, between reference and new. So it is type 1 modification. ZK, K is equal to ZB will be taken here. So Z11 will be equal to ZB, that is J point or J1.2. Other things will not be applicable because we are doing it from scratch. Then in the next step, he has asked us to add between 1 and 2. That is this one. So 1 and 2. 1 is old, 2 is new. Type 2 will be followed. K is 2, J is 1. Same formula. Many times already we have discussed about type 2 modification. So after substitution, we get J1.2, J1.2, J1.2 and 1.4J as our updated Z bus. And in after that, he has asked us to add between 3 and 1. So between 1 and 3, if we add, 3 is new bus, 1 is old bus. So between new and old, it becomes type 2 modification. So K will be 3, J will be 1. Since type 2 is being repeated, same approach and formula will be used, numbers will differ. So once this is done, we'll be getting this as our final Z bus. Then as per the problem, after adding element between 3 and 1, we have to add between 4 and 3. So between 3 and 4, if you try to add 3 and 4, 4 is reference, 3 is old bus now. Yeah, so it becomes type 3 modification. So J will be 3, reference R will be 4. Z bus new will be equal to Z bus old minus 1 over ZJJ plus ZB, Z1J up to ZNJ. Totally 3 buses are there. We have to omit reference in this particular column and row matrix. So we'll just be taking Z1J, Z2J, Z3J. Here we'll be taking ZJ1, ZJ2, ZJ3. Fourth one will not be considered since it is reference. So we have Z13, Z23, Z33, Z31, Z32, Z33. So then Z33, Z13, Z23, Z33 as usual, we'll be picking all these elements from previous updated Z bus. Then ZB is nothing but in the branch impedance included in this step, which is J1.5. After the simplification, the second term turns out to be 0.48J, 0.48J, 0.6J, 0.48J, 0.48J, 0.6J, 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 0.75J. Now the last part left over will be to subtract the second term from our old Z bus, that is our previous updated Z bus. So once that is done, we get 0.72J, 0.72J, 0.6J, 0.72J, 0.92J, 0.6J, 0.6J, 0.6J and 0.75J. This completes sample problems on Z bus from module 5. Any number of problems solved further will be of the same type.